The modern commercial grid relies on a heavy workhorse to deliver massive amounts of power, the three-phase electrical system. This animation shows how the system is designed to work. You have three separate currents, each perfectly offset by exactly 120 degrees. Because of that precise mathematical spacing, when these currents meet to return to the source along a single shared neutral wire, they cancel each other out to zero. For decades, engineers trusted that mathematical perfection. Building codes allowed construction crews to save money by severely downsizing those neutral wires, and they rarely bothered to install circuit breaker protection on them. That means the physical skeleton of nearly every older office building was built on a very specific assumption of perfect electrical balance, an assumption that no longer holds true. Look at the early computer workstations that flooded offices in the 80s and 90s. These devices broke that perfect balance. Unlike a traditional light bulb or industrial motor, modern electronics don't draw power in a smooth, continuous flow. They gulp it in abrupt, distorted pulses, injecting a massive amount of electrical noise backward into the building's wiring. That noise takes the form of specific rogue frequencies, known as Triplen Harmonics, specifically the 3rd, 9th, 15th, and 21st multiples of the standard power line frequency. Because early building codes didn't anticipate these frequencies, simply plugging in a floor full of standard office equipment can create a cumulative, invisible fire hazard deep inside the walls. Normal electrical noise often cancels itself out within the wiring, but triplens behave differently. Engineers classify them as zero-sequence currents, meaning they share a highly destructive behavioral trait. This diagram shows the math behind the problem. Because triplens are exact odd multiples of 3, that standard 120-degree offset we saw earlier doesn't separate them. Instead, it perfectly aligns their peaks and valleys. When these specific frequencies hit the neutral wire, they arrive at the exact same time, completely in phase. Instead of canceling out to zero, they stack. They combine cumulatively into a massive, aggressive surge of energy. That stacking forces the thin, unprotected neutral wire to carry anywhere from 173 to over 300% of the normal current it was designed for. The exact math originally used to ensure a perfectly balanced grid is the same math these rogue currents exploit to cause catastrophic overloads. The overload travels upstream from the building's wiring to launch a direct assault on the heavy distribution transformers. Triplens get physically trapped inside the specific triangular configuration of the transformer's copper coils, circulating endlessly in a closed loop. This trapped circulating current acts like a massive internal heating element. It cooks the wire insulation, slashing the hardware's lifespan from decades to mere months. Because of this invisible electrical noise, the grid quietly incinerates its own most expensive infrastructure from the inside out. To stop these fires, modern electrical codes now mandate brute force solutions. Electricians are required to pull double-sized neutral cables or run completely separate neutral wires for every single phase. But there is also a more elegant defense deployed at the hardware level: isolation transformers, designed specifically for harmonic mitigation. This schematic illustrates a delta-Y winding geometry. Engineers use this triangular loop to trap rogue zero-sequence currents. The triplens circulate within this loop, neutralizing themselves as heat, preventing them from traveling upstream into the grid. By simply manipulating the physical shape of copper wire, engineers can correct a mathematical corruption of the power supply. For complex facilities, the standard for suppression is the active harmonic filter. This animation shows how an active filter reads the electrical distortion in real time, then instantly injects an exact inverted mirror image of the rogue wave, canceling the noise out completely. Modern electronics have established a high-frequency demand on our infrastructure that building codes are only now beginning to recognize. Triplens remain a severe architectural risk, but by deploying the right mitigation gear, we can keep the grid balanced, the hardware cool, and our buildings safe.